Hi, and this is section 6.3, solving multi-step inequalities. And I think you're going to find that chapter 6 in solving inequalities, this is really a lot of review of what we learned in chapter 3 where we were solving equations. I taught chapter 3 the same way. In chapter 3 we worked on solving one-step equations first, then two-step equations, and then multi-step equations. Here we've worked on the one-step inequalities. And we emphasized in the last video that when you multiply or divide each side of an inequality by a negative, you have to reverse the inequality symbol. Today we're just going to work on multi-step inequalities, and I think you're going to see the steps for this are things that you learned back in chapter 3. I think the easiest thing to do would just be to do some questions together and graph these after. So go to page 372, and I'm just going to do, like I said, just review and works through some of these with you. Let's go ahead and we'll start off with number 3. That's an easy one. It says 2x minus 3 is greater than 7. I want to solve this inequality. Well, this is going to take a couple steps. Step 1, I always want to try to simplify. I can't either side, so I got to get rid of minus 3. I'm going to add 3 to each side. And 2x then is going to be greater than 10. I still haven't solved for x, so to get rid of the times 2, I got to divide by 2. And that means x is greater than 5. Okay, there's my solution. X is greater than 5. I want to graph that, so I'm going to go to, let me enlarge this. There we go. I want to go to 5. I want an open circle at 5. It didn't say equal. I want values that are greater than 5. There would be a graph of that situation. Okay? Going back here then, let's do another one. Let's move ahead and let's do number 7. Just picking a few to do. Okay? We have 7 times r minus 3 is greater than or equal to negative 13. Now remember, the first step would always be to simplify if possible. Actually, we could do this problem in 2 ways. Remember, we could divide each side by negative 7 first if we wanted to. That would be inverse. But I'm gonna distribute. I'll simplify first. So 7r minus 21 greater than equal negative 13. I got to get rid of minus 21, so I'll add it to each side. So I have 7r greater than equal positive 8, and I'll divide each side by 7, and I'm finding r is greater than or equal to 8 sevenths. 8 sevenths. Let me write that down better. Okay, I need to graph that, so I will go to my number line. I will put a closed circle at 8 sevenths, which is just past 1. And I said it was greater than that, so there would be a graph of that, arrow pointing right. Okay? Let's do another one here. I'm just moving around trying some different questions. What about a question like number 10? Okay, now in number 10 we have 8n minus 2 is greater than 17n plus 9. Pen isn't responding great here. There we go. Let me get this out of the way. All right, so remember, always try to simplify each side. I can't, but next thing, remember from chapter 3, if I have variables on each side, I don't want that. So I'm going to take away 17n from each side. I like having my variables on the left. It's just a personal preference, but that's how I like it. So I'm going to have 9 on the right, and I have negative 9n minus 2 on the left. Okay, so my next step, I have to add 2 to each side. So when I add 2 to each side, I have negative 9n on the left, and I have positive 11 on the right. Okay, next step. My next step, I have to divide each side by negative 9. Now when I do that, I'm going to put a little star next to this, and very important, remember, just in our previous video, remember, this was a super important step here, right here. When you divide or multiply each side of an inequality by a negative amount, remember, you must reverse the inequality. So this inequality must be reversed. And I get n is less than, now this would be, well, negative 1 2/9. Or I guess you could just keep it as negative 11/9. Okay, I must reverse the inequality when I multiply or divide each side by a negative. So I did reverse the inequality here. Okay, so I want to graph that now. So I'll go to negative 1 2/9, which would be about over here. I'm using an open circle because it said less than, it did not include equal, and I want the values that are less than that. So I'm arrowing to the left. Okay? So again, just doing multi-step equations. Let's do another one. Now, if you go down to question 17, go down to question 17 through 28. It says, solve the inequality if possible. Let's review back in chapter 3. Remember, when you solve an equation, there's one of three things that can happen. Okay, solving an equation, you can get one solution. Maybe I'll just write these down. When you solve an equation, okay, when you solve an equation, one of three things can happen. You can get one solution, you can get no solutions, or you could get infinitely many solutions. Okay, and infinitely many solutions, we call that identity. Okay, when we solve inequalities, the same things can happen. We can't get one solution. If you look here, this is not one solution. X is greater than 5. It's anything greater than 5. But we could get a solution that gives us an inequality like this, where we're saying X is greater than a certain amount or less than a certain amount. That's one scenario that can pop up. But we could also get no solutions, or we could find that anything works. Okay? So let's take a look at when that might happen, and what you'll notice is it's what we learned in chapter 3. When the variables disappear as a result of doing your work, that's when we know we have either infinitely many solutions, identity, or no solutions. So let's look at 17. And question 17, it says 3p minus 5 is greater than 2p plus p minus 7. Now, of course, we should try to simplify first. So over here, I can't subtract those. Now, over here, I have some things I can simplify. I have 3p minus 5 on the left, but over here, that's 3p minus 7. Well, I don't want p's on each side, so I got to get rid of this positive 3p, so I'll subtract it. And notice what happens when you subtract. Those cancel out. Those cancel out. I have negative 7 on the right, but over here they do too, and I get negative 5. Is negative 5 greater than negative 7? Think about a number line. Is negative 5, which is here, is that bigger than negative 7? And the answer is yes, it is. Negative 5 is farther right. Okay, well, this would be an example then. This would be an example of, we have identity. We have all real numbers, okay? All real numbers are solutions. So in other words, I could plug in anything I want for p. I could pick 1,000,000, plug it in, and this side will be bigger than this side. I could pick negative 18, and this side will be bigger than this side. It doesn't matter what I plug in, okay? This side will always be bigger or greater than this side. And I think you might recall from chapter 3, when you are working out an equation and those variables disappear, that's when we can have these situations of identity, all real numbers, or no solution. It's the same for inequalities. Let's do another one. like, let's look at 23. And 23, it was 6x plus 3 is less than 5x plus 18 plus x. Okay, and I want to solve this inequality. So obviously I have simplifying I can do on each side. So let's simplify here. I get 6x plus 18. And let's simplify over here. I have 6x plus 18. And if I take away 6x from each side, I notice my variables completely disappear, and I'm left with 18 less than 18. Is 18 less than 18? And you're probably thinking, no, it's not. It's the same. It's equal. Okay, so then this is a false statement. This equation, or this, I misspoke, this inequality then has no solutions. In other words, there's nothing I can plug in for x that will make this side less than that side. Okay, this is a false statement. So the difference is here I had a true statement in 15, and that's why I got all real numbers as my solution. Here I have a false statement for 18, and that's why I had no solution. Okay, so it is possible that you can get a solution like x greater than 5. You could get a solution. Or you could have identity, which is all real numbers, as a solution, or you could get no solution. So there's three different cases, just like we had when we solved an equation, three cases. In inequalities, there's three different events that can occur. We can get a solution or an inequality that's showing x is greater than or less than a certain amount. We could get all real numbers as our solution, identity, or we could get no solution, okay? One last thing I wanted to walk through. If you go through questions like 29 through 32, I'm going to give you a worksheet tomorrow that will give you additional practice on this. It's translating a phrase into an inequality, then solving the inequality and graphing it. So, for example, in 29, 4 more than, that means we're adding 4 to something. 4 more than the product of 3 and x, product means multiply, so we're taking 3 and x, multiplying it, and adding 4, is less than 40. Okay? There is an inequality. I translated the verbal phrase into an inequality. All they want me to do now is solve this inequality and graph it, so that's easy enough. I can take away 4 from each side. This is a review of stuff we've done. 3x is less than 36. I can divide each side by 3 then, and x is less than 12, and then I can graph that. Okay? I think this covers what I would want you to know, or the basics of what this video is about. And I think that covers it all. Okay? If there's any questions, we can go over those in class tomorrow.